Okay guys, so this is a review of last year's proportional relationships. So just to remind you of the important vocabulary that we are going to be using, the first is independent variable. And so I like to think about this as the variable you can control. And in our case, it'll always be x. X is always going to be the variable that we can control. The dependent variable is the variable that depends on the independent variable, which I like to shorten as IV. And in our case, we will use y to represent the dependent variable. So independent variable, you can control, you can change it. Dependent variable will change as you change the independent variable. The unit rate is how much 1 unit is worth. So it depends on what your variables are, but the unit rate is what you get when it's just down to 1 unit. And then the constant of proportionality is the ratio, which means to really divide, the ratio of the dV to the IV. So in another way of saying it, the constant of proportionality is y divided by x, because ratio just means division or to be written as a fraction. So when I find the constant of proportionality, I'm going to be dividing y by x. And so what we're going to see in this video is that proportional relationships can be written as a table, as an equation, and as a graph. So we're going to use Olivia as an example. She always charges the same rate for babysitting. On Saturday, she can earn $30 in 5 hours. So we're going to represent that as a table, equation, and a graph. But before we do that, we need to know what the two variables being compared are. And so we can see first that it's dollars and hours. Those are the two things that are being compared here. And so the independent variable is what I can control, or in this case, what Olivia can control. Can she control how much money she makes? No, but she can control how many hours she works. So this is going to be my x variable. The dependent variable is money, or the dollars. The dollars she makes depends on how many hours she works. And so they told us that she makes $30 in 5 hours. So that's not a unit rate. That's not how much she makes in 1 hour. So to find the unit rate, I'm going to take the IV, or the DV rather, and divide it by the IV. So to figure out how much she makes for 1 unit, we're going to take $30 and divide it by the 5 hours she works, which is going to give me that her unit rate is $6 per hour. So for 1 hour, she makes $6. So when we make our table, we want the top to be our IV, or our x value, and we want the bottom to be our dV, or our y value. So our x value is the number of hours she worked, and the y value is how much money she makes. So if she works 0 hours, and we always want to start our tables at 0, she's going to make $0. And then on the last page, we found that if she works 1 hour, she's going to make $6. And since she's making $6 per hour, if I add on another hour, I know she's going to make $12 in total, because I'm adding $6 for every 1 hour that she works. So if I add on another hour, I need to add on another $6. So for 3 hours, she'll earn $18. For 4 hours, I'm going to add on $6 again. She would earn $24. And we get to 5 hours is $30, which is what the information in the problem told us. So in the table, one really important thing that you're going to notice is that it starts at 0, 0. All proportional relationships start at 0, 0. So 0x and 0y. And it goes up at a constant rate. So now let's take a look at our graph. So along the bottom is our x-axis, so we're going to label that hours. And let's just go up by 1. So we start at 0, 1, 2, 3, 4, 5. Let's do that. And then along this axis, our y-axis, we're going to label it dollars. And let's go up by 6, since that's our unit rate. And we're going to plot a point for every value in our table. So for 0 hours, she made $0. 1 hour, she made $6. 2 hours, she made 12. 3 hours, she made 18. 4 hours, she made 24. And 5 hours, she made 30. And if we connect those dots, we'll notice that we get a straight line. So proportional relationships, again, always start at 0, 0. So you can see that on this graph. It starts right here at 0, 0, right at the corner. And then it also, you notice, is a straight line. All proportional relationships are a straight line. Okay, so the new thing for us, or it may not be new, is writing an equation. So this equation is going to allow us to figure out how much money she makes for every possible hour she babysits. And so our equations always go in this format. They always start with y equals, and then we're going to do something times x. So remember, y is how much money she makes. So y is how much money she makes. To get how much money she makes, we need to take however many hours she worked and multiply it by the constant proportionality, or the unit rate. So 6 is the unit rate, but it's also the constant proportionality. It's what we get if we do y divided by x. So this is the equation. This number here is going to be the constant of proportionality, COP. Or you could think of it as the unit rate. And you can kind of see how it works. Let's say she works 7 hours. If she works 7 hours, to figure out how much money she makes, I need to multiply it by 6. So she makes $42 if she works 7 hours. And that's exactly what this equation says. So we looked at how we could find the constant of proportionality in a table, graph, and equation. So in a table, the constant of proportionality is how much y increases. In the graph, the constant of proportionality is what we call the slope. We're going to talk more about this word later. And then in the equation, the constant of proportionality is the number in front of x. And so we saw that the unit rate was $6 per hour. The constant of proportionality was also $6 per hour. So really, the unit rate and constant of proportionality are the same thing. So maybe you can think of like unit rate as being the old name for constant proportionality. We're going to be using constant of proportionality in this unit.